Hello everyone. Today we are going to talk about 5.2b odd and even functions graphically. So we are going to determine if the functions are odd function, even function, or neither graphically. But before we start the lesson, can you go over the do now? So I'll give you about 2 minutes. Okay, let's go over together. So we are going to describe the end behavior of this function y equal to negative x to the third power plus 3x squared plus 10x, right? So what's the degree? Degree is 3, right? And then sign of leading coefficient is negative. So if you draw the graph in the calculator, you can see like this. And degree is 3 and leading sign of leading coefficient is negative. Then we know that when x goes to negative infinity, it means when x decreases, what happened to y? When x goes to this way, what the function goes up. It means y goes to the positive infinity. And then what happened when x increases? When x increases, when x goes to the positive infinity, y goes down. It means y decreases, right? So y go to the negative infinity. Does everybody understand? It's easy. All right. So today's lesson. What is even function? Even function is function which are symmetrical about the y-axis. You know the y-axis is here. And then we want to see if the function is symmetrical over this line. So look at the right side or left side, right? X positive side and x negative side, we compare if they are exactly matching, symmetrical, then this is even function. So y equal to x squared is the even function, right? How about this one? Oh, this absolute value function is also even function, right? Because it's a symmetry over y-axis. This is, we call, in the trigonometry, this is a cosine function, right? Cosine. Then this is also symmetrical over y-axis. So we can say this is also even function, right? So for example, so if you see as an example 5, x squared, x to the fourth power, x to the sixth power, they are all even exponents are all even numbers, right? Even degree functions. 5, if you remember, is x to the 0 degree, right? X to the 0 power, degree 0 for the numbers. So 0, 2, 4, 6. Do you see the patterns? So if you see characteristics, exponents are all even numbers and constants, what happened? Like a 5 here, constants also, exponents are even number because it's 0. Again, how do you determine? We compare when x is a negative, so we call f of negative x, and then we compare with the f of x is positive side, negative side, and positive side. We compare if they are equal, y value, the function y values are equal, which means symmetry over y-axis, right? Then they are even function. So changing sign of x doesn't change y values, all right? So if you see that these are not even functions, all right? This is not even, this is not symmetry over y-axis. You look at this, what, there is nothing here, right? It's here. This is also not symmetry over y-axis. This one looks similar, symmetry over x equal to something 0 point something, right? But it's not over y-axis. It's slightly moved to the right side, so it cannot be symmetry over y-axis, so it's not even function. All right. How about then other function? Other function is function which are symmetrical about the origin. It's not x-axis, all right? It's origin. If anything is symmetrical about the x-axis, it cannot be a function, all right? So, so it's about the origin, the point here. So then we can say this is a other function. So if you see any point here about the symmetry about the origin, so you go, the origin is here, then opposite side is here, right? You have a point there. Then it's symmetry, right? You pick any point in the right side here, and they go to the opposite side of about the origin. Then do you see here? Yeah, that will be the other function. Mostly it happens when not mostly, all the time, when the exponents of the variable is odd. What happened to x here? Yeah, there's a 1, but it's invisible 1. 135, right? This is x cubed. It's a cubic function, like this. How about this one? You have a point here. If you cross through the origin, and you can find the point opposite side here, right? Over the origin. How about if you pick this point, you keep going to the origin from the, you pass through the origin and go to the same distance over here. Yes, you can find another point there. So this is, we can say symmetry about the origin. Then this will be other function. In trigonometry, this we call sine function, right? Sine. So exponents are all odd numbers. So when we compare the negative side and positive side, you know that sign changes, right? So negative become positive here, positive become negative in there, right? So y value sign changes. How do you sign changes? You multiply negative. So then this is other function. Does everybody understand? So how do you do it? F of negative x is equal to what? Negative f of x. So you compare the negative side with the positive side, sign changes. That's the other function. If there's a sign, if there is no negative, it was even function, right? So this was even function, so it's not other function. But this one, is it even? No, not even. Is it odd? No. It should pass through the origin, and then you should get the point. So if you pick any point here, right? Let's pick a point from here and draw a line through the origin, and then go pass through the origin and go to the same distance like this, then you should have a point here, but it's not, right? It's not, then it's not symmetry over origin. It's not symmetrical about the origin, so it's not other function. It was shifted a little bit higher, right? Shifted up. So how about this one? This is not other function. This is not even function. It's a neither, we call. All right, it's neither. Neither even function. Okay, these are the other function. So does everybody understand? Okay. So can you look at the graph of each function and sketch briefly? So you know how to, put these functions in the calculator, right? So can you try now and look at the function? Okay. So x squared plus 4. If you put into the calculator and draw the graph, it will be like this. Then what do you see? Is this, what kind of function is this? Yeah, see, it's a symmetry over about the y-axis. So when x is positive, when x is negative, you compare both of them has the same y values each time, right? Oh, this is even function. So if you look at the function, you can see that exponents are all even numbers. X to square, how about 4? You can, we already know that x to the 0 power, right? For the constant numbers, the 0 is even number. So all even number powers. All right, how about B? If you draw the graph, how do you draw the graph? Like this. Does it look like what? Symmetrical about origin, right? You pick this point, if you pass through the origin, and you can go up to here. You see a point, right? If you pick a point from here, then go through the origin, and same distance you go, or you meet a point here too. So like this, you pick anywhere and pass through the origin, and then go same distance, you will see another point there. So this is symmetry about the origin. Then we can say this is what function? Other function. But if you look at the original function, look at the exponent, right? They're all other numbers. Easy, right? So we can say this is what? Other function. How about the third one? Can you determine then without looking at the graph, with just look at the exponents, by looking at the exponents only? What do you see? 2, 1, this is x0 power. So 2, 1, 0 degrees. It's mixed, right? Then what do you expect? Is it odd? No. Is it even? No. Because it's mixed, then it cannot be odd function, it cannot be even function. Then it's neither. The graph will be like this, right? Yeah, it's not a symmetry over origin. Then if it is even, you should have like this and like this. Anyway, it's not even function. Also, it's not symmetry about the origin. You don't have any point here. This one should be here, right? So it's not other function, as you see. So it's neither. Does everybody understand? Okay, we are done here.